Technology sometimes, hate it other days, but today we're going for it. So we're going to talk about an infinite geometric series, and we're going to show you how sometimes an infinite series can actually reach a number, or in other words, converge. And you might think to yourself, how can an infinite series actually reach a sum? And well, I'm going to show you. So an arithmetic series, okay, an infinite arithmetic series will never reach a sum, because if you're adding a number, the same number every time, then it's going to go, then when you add them all up, it's going to go to infinity, which is not a number, it's an idea, and it's just going to keep going big and big. If you subtract the same number every time, then that's going to, and you add all those up, that's going to go to negative infinity. And again, it's not a number, it's an idea. So therefore, an infinite arithmetic series will never converge. It will always diverge, which means it has no sum, and it'll never go to a single value, and it increases or decreases without bounds. So let's take a look at this series right here. -6 plus -1, that's adding 5. -1 to 4, add 5. 4 to 9, add 5. So you're adding 5 every time. And look at these numbers: 4, 9, 14, 19, 24. They're just going to keep getting bigger and bigger and bigger. And as you add them, they're going to go to infinity. So my first term was -6. The common difference here was 5. And this thing is going to diverge, or in other words, not have a sum, because it's going to go clear out to infinity, which infinity we all know is not a number, but just an idea. So, infinite geometric series that converge. What? We can have an infinite series that converges? Well, yes. Not all of them do. In fact, let's take a look. Look at these numbers here. 1, 2, 4, 8. What are they doing? Well, you're multiplying by 2 every time. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So we're going to get 16. We're going to get 32, 64. And it's just going to keep getting bigger and bigger and bigger. So my initial number was 1. Common ratio was 2. But these numbers are getting bigger and bigger. So as I add them up, they're going to get bigger and bigger. This thing is also going to diverge. This baby has no sum, because as I add them up, it's going to infinity. All right? These numbers are getting huge, and it's just going to head that way. Take a look in contrast now to this one here. All right? Take a look at this one here. 1 plus a half, plus a fourth, plus an eighth, plus a 16th. What are these numbers doing? Well, they're multiplying by a half every time. So this was 1, and we're multiplying by a half every time. Look at the numbers we're going to get. 1 over 32, 1 over 64, 1 over 128, 1 over 256, 1 over 512, 1 over 1024, 1 over 2048, 1 over 4096, 1 over 8192. I mean, the bottom number keeps getting really, really big, while the top number stays to be a 1. And what happens when you take 1 over a really, really, really big number? It gets really, 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 really close to 0. That's right, it gets really close to 0. So, if that's the case, the number that I'm adding out here is getting closer and closer to 0. At some point in time, it's not going to change the numbers that I get when I'm adding all these together. This thing is going to converge. Biggest way I could tell is because these numbers are getting smaller and smaller and smaller and smaller and closer to 0. Now, not my sum. My sum's not getting closer and closer to 0. Just the numbers that I'll be adding to the numbers will get closer and closer to 0. In fact, we could kind of take an idea. I mean, let's take an idea. Let's look here and see. What is this thing going to get really close to? Let's go ahead and take 1. So in my calculator, I'm just going to add some of these up, okay? So 1 plus a half, plus a fourth, plus an eighth, plus a 16th, plus a 1 over 32, plus 1 over 64, plus 1 over 128 plus 1 over 256. We'll stop there. That gives me 1.996. So right to here, 1.996. Let's see what happens when I add some of these other numbers to it. So plus 1 divided by 512, plus 1 divided by 1024, plus 1 divided by 2048, plus 1 divided by 4096. I get, so all the way up to here, 1.999756 going on, right? Well, let's add one more. 1 plus, sorry. Oh dear. Oh dear. Oh dear. We had 1.99756. It was bigger than that, but we'll just, trust me, plus 1 divided by 8192. And I still just get at 1.99. Oops. Sorry, 1.999756 plus 1 divided by 8192, and I get 1.9998780. So what is this number getting really, really close to? It's getting really, really close to 2. So this thing is going to converge onto 2. What's the biggest difference between these two? Well, these numbers are getting really small, getting close to 0. These numbers are getting really big, close to infinity. Look at your ratios. This had a ratio of 2. This has a ratio of 1/2. Oh, when that ratio makes the next number become smaller, that's how we can tell it's going to converge. If the ratio makes the next number become bigger, that baby's going to diverge. Let's go ahead and take a look and see if we can figure that out through here. Let's look at them. Look at these numbers, 1, 2, 3, 4. What are they doing? They're getting bigger. It's arithmetic because you're adding 1 every time, but they're getting bigger. This thing is going to diverge. Look at here. What's happening to the numbers? 1, 1/2, 1/4 of 8. They're getting smaller. They're getting closer and closer to 0, which means this thing's going to converge. Look at these numbers. What are they doing? 1, 2, 4, 8, 16. They're getting bigger. Diverge. Look at these numbers here. Oh, wait a minute. We don't have numbers. Well, let's find them. Plug in a 1. 1 minus 1 is 0. 2 to the 0 is 1. 1 times 5 is 5. Plus. Now go to 2. 2 minus 1 is 1. 2 to the 1 is 2. 2 times 5 is 10. Plus. Go to 3. 3 minus 1 is 2. 2 to the third is 8. 8 times 5 is... Oh, sorry. 3 minus 1 is 2. 2 squared is 4. 4 times 5 is 20. Oh, we're multiplying by 2 every time. That's right, because there's our common ratio. What are these numbers doing here? They're getting bigger. Diverge. This is easy. It's so easy to tell if it's going to converge or diverge. Just take a look at your series. If the numbers get bigger, diverge. If the numbers get smaller, converge. And soon, these numbers will be so small, they'll be so close to 0, they won't have any bearing on what you're going to get out. So, let's take a look here. How do we find that formula? How do we find a formula? Because, I mean, it'd be so much easier if there's just a formula. Well, you can use this general formula that we had at the very beginning. We use this for non-infinite, so for finite geometric series, adding them up. Well, let's take a look if we now let n go to infinity. Well, if I have an r that's bigger than 1, absolute value of r bigger than 1, say like 2 or 3 or 4, and I take it to an infinitely large number, that is going to go to infinity. That baby's going to infinity. It's going to get infinitely large. What is, if I had the absolute value of r equals 1, so basically if r equaled 1, what would be 1 to the infinite? That's going to be just 1. That's going to be 1. 1 times 1 times 1 to 1. How many times you multiply 1 by itself? It's going to be 1. Now what happens if I let r be less than 1? Well, if the absolute value of r is less than 1, what does that tell us? Well, that's an interesting thought. I get, let's say it's like 1/2 or something to the infinitely large number. That's going to be 1 to infinity over 2, which is bigger than 1, all right? So 2 to infinity, which is going to be 1. That's what we said that equaled, over an infinitely large number, because that's what we said any number to an infinite power is infinity. Constant divided by an infinitely large number will always go to 0 every time. So what ends up happening is this portion right here, if the absolute value of r is less than 1, this portion is going to go to 0, and we're going to get that equation. So for infinite geometric series, this is the equation you want right here, infinite geometric series. All right, so let's use it to help us find all these things. All right, so A, what's your first term? 1. What's my common ratio? If you don't see it, take the second term, 1/2, divided by your first term, 1. That'll tell you what it is, 1/2. That's your common ratio. So my common ratio is 1/2. The absolute value of 1/2 is less than 1. This thing is going to converge. What's it going to converge on? Well, I take A, using my equation right here. I take A, which is 1, over 1 minus the ratio, which is 1/2. 1 minus 1/2 is 1/2. That's going to be 1 over 1/2. So therefore, multiply by 2, because you can't divide by a fraction. So this thing is going to go to 2. It'll never really actually reach 2. It'll just get really close. Okay, number 9. Take a look. A is 4. My ratio, well, 8 divided by 4 is 2. If you're not sure about it, take 16 divided by 8. That's also 2. Okay, ratio is 2. The absolute value of r here, the absolute value of 2 is bigger than 1. This thing is going to diverge. Has no sum. No sum. Okay? Take a look here. What's my A? My A is 3. What's my ratio? Well, if you don't know, take the second term, -3 over 2, divide by the first term, 3, which is really 3 over 1, multiply by its reciprocal, because you can't divide by a fraction by a number. 3 simplify, giving you -1/2. So my ratio is -1/2. Ooh, the absolute value of -1/2 is less than 1. This thing is going to converge. What's it going to converge to? Well, I take my first term, 3, divided by 1 minus my ratio, -1/2. So add those together. That's going to lead me to 3 divided by, get a common denominator, which is 2. So 2 plus 1 is 3, so 3/2. Multiply by the reciprocal. 3's are going to simplify. It's going to 2. It won't always go to 2. It just did in these cases. So just trust me. It won't always go to 2, okay? Trust me. All right, let's take a look here. It says the length of the outside shell of each enclosed chamber of a nautilus is 0.9 times the length of the larger chamber next to it. And they give us this right here saying this is the beginning of the enclosed chambers. This part here is open. This is the enclosed chamber, the closed chambers, okay? So what's A? A is 27 millimeters. My ratio, they says 0.9 times. It's getting smaller and smaller and smaller and smaller and smaller and smaller and smaller. If I add them all up, what am I going to get? Well, using my formula right up here, I'm going to take my initial amount, 27, divided by 1 minus my ratio, 0.9. That's going to give me 27 divided by 0.1, which is going to take us to 270 millimeters. You add them all up, that's what you get. Ka-ching! All right, folks, we are done. Have a wonderful day, and we'll see you later. Adios.